Hi everyone, this is your teacher Henry, and today lesson we will discuss about the integration by substitution. So the prerequisite for this topic is the knowledge of the chain rule in the differentiation. I assume that everybody here knows about the chain rule in differentiation. So proceeding with the topic for today, uh, we will discuss about the integration by substitution. So in this section, you will study techniques for integrating composite functions. The discussion is split into two parts: pattern recognition and change of variables. Both techniques involve a U substitution. With pattern recognition, you perform the substitution mentally, and with change of variables, you write the substitution steps. The role of substitution in integration is comparable to chain rule in differentiation. So we first start with recognizing the pattern. So we have to recognize in the form of g of x multiplied by g prime of x pattern. So example one, we have the integral of x squared plus 1 raised to 2 multiplied by 2x dx. So as you can see, this 2x is the derivative of this inner functions. So if letting g of x equals x squared plus 1, so we get the derivatives of the inner function g of x equals 2x, which is exactly this one. And f of g of x equals f of x plus 1 equals x squared plus 1 squared. So it is in the form of this function. So we can integrate it directly using our formula, which is the answers will be the integral of the outer function, which is the this one, x squared plus 1. The integral of this whole function is x squared plus 1 raised to cube over 3 plus c. So this is the final answer for this one. So kung mapapansin natin, so ito yung 2x natin, which is exactly the same this one, and the f of g of x is this one. So i-integrate lang natin itong part na to, itong the whole part. So ignore natin yung inner function, just integrate this, and then we get the integral of this function of this term is equals to this term raised to cube over 3, which is equals to this function. Okay, let's proceed with another example number 2. So we have this the integral of 5 cosine 5x dx. So with letting g of x equals 5x and g prime of x equals 5, f of g of x equals f of 5x and equals cosine 5x. So kung papansinin natin, so ito, we can rewrite this as, we can transpose this into here para mas madali natin makita, which is cosine 5x 5 dx. So this function follows this pattern. So integrating this one, we just need to get the integral of cosine, which is sine, and then we proceed with the final answer, which is sine 5x plus c. In other cases, meron tayong mga functions na it involves a certain factors, a numerical factors, which is in the form of this one. So in that case, this is called the constant multiple rule. We just kick out the constant outside the integral, and we proceed with our integration by substitution process. So let's take the example number 3. We have this expressions. So we have the integral of x multiplied by x squared plus 1 raised to 2 dx. So letting g of x equals x squared plus 1 and g of prime equals x, g of prime x equals 2x. So the derivatives of this one, the inner function is 2x, and copying the outer functions and proceeding with the integration process. So we have this one. And as you can notice, we have 2x here, but we have only x here, x dx. So we need to introduce a factor that, and so that we can have a 2x in this expression. So we introduce 2x here, dito. So para mabalance natin siya, and we will multiply it by 2. So we are not changing the expression, but we are only changing its forms, but the expression is still the same. So later on, we can kick out this one by constant multiple rule. So it becomes 1/2 over and the integral of x squared plus 1 raised to 2x dx. So meron na tayong pattern na kamukha nito. So proceeding, we integrate. So we have this expression, and then we further simplify, we get the final answer 1/6 multiplied by x squared plus 1 raised to cube plus c. So this one we will just kick it outside and multiply it by this term, and we have 1/6. Numerical factor of the final answer. Okay. And now we proceed to the chains of variables. In the chains of variables, we have this pattern, the same pattern, and we want it to convert into the f of u du, so that our answer is the integral of u plus c. So we proceed with the example. So let's say we have the integral of square root of 2x minus 1 dx. So we proceed by letting g of x equals u equals 2x minus 1. So this one is our u, and g of prime of x, so we get the difference, the derivatives of the inner function, which is du equals 2 dx. And solving for dx, kailangan natin makuha itong dx na to. We have dx equals to du over 2. Thus, the square root of 2x minus 1, we let this as u here. So when we express the integral in terms of u, we will this one will become the square root of u. Okay, and dx equals to du over 2. So proceeding in integral in terms of u, so we have this form, and then by constant multiple rule, we will kick out this denominator. We will kick it outside. We have 1/2 multiplied by the integral of u raised to 1/2. So this integral we will convert to a fractional exponents, so that we can derive integrate it easily. Then integrate in terms of u, we have these expressions, and then in the final answer, don't forget to substitute back du 2x minus 1 for u, and we have this final answer, which is 1/3 u raised to 3 over 2 plus c. So this is now our final answer after substituting 2x minus 1 for u. Again, example number 5. So in most cases, we have to solve for x. So sa previous example natin, so we get the dx part as exactly as it is, katulad ng given. But for this time, it's a little bit different. Meron tayong extra factor na x outside dito. So which we need to compute in terms of u. So here how it proceed. So letting equals 2x minus 1, so it's still the same. So derivatives of this one is d equals 2 dx. And further computing for dx, we have du over 2. Because the integrand contains a factor of x, like what I've said kanina, you must also solve for x in terms of u as shown. So from this one, from u, we will solve x in terms of u. So x equals u plus 1 over 2. Then proceeding, we will substitute this. That's why it's called the u substitution. We will substitute the u in this original integrand. So we have here the integral is equals to u plus 1, which is over 2, which is the x part. And this is the square root of 2x plus 1, 2x minus 1, and the dx is du over 2. So this is the dx. So by constant multiple rule again, so we kick out all the constant variables and we proceed with the integration. So simplify the integrand. So we will distribute this one. We have this expression and integrate in terms of u. We get this answer. And simplifying and substituting back 2x minus 1 for u, we have this as our final answer. Okay, example of 7. These are change of variables for definite integrals. So it's basically the same process, but we just to evaluate the integrals within their limit. So example number 7, we have this given, and before substituting, determine the new upper and lower limits. So in this case, there is a trick. We before substituting in terms of u, so we need to determine first the new limit. So this is how it goes. Let u equals x squared plus 1. This is the inner function. And du equals 2x dx. Then we will compute the lower limit when x equals in terms of u. Kasi substitute natin to back to the in terms of u. So the lower limit when x equals 0. So we just substitute the 0 from this expression. So we have u equals 1. And when the upper limit, when x equals 1, substitute it to this expression and we get u equals 2. And going here, the integration limit for x, we have here 0 and 1, but magbabago yan pagka i-integrate natin in terms of u. So these are now the integration limit for u, which is 1 and 2. We will work on this equation. So we have this form now. We have u cubed x dx. So integrate in terms of u. So we have here u to the 4th, the integral of this one over 4, and performing this operation, the upper limit minus the lower limit. So we have here as a result, and the final answer will be 15 over 18 after doing the simplification, the calculation and simplification.